Howdy folks, this is Tom Bartley here again. We're now looking at being.c, and this is all with the 690 version of the source code. Just a little footnote with that. Source code does change a bit, but my feeling is a lot of this stuff will probably remain relatively similar, so I hope this audio doesn't date so quickly. Anyway, so we are now looking at being.c. This currently contains everything associated with the Noble Ape. When I reintroduce the fierce feline code, there's going to be some very interesting stuff going on at being.c associated with apes and felines living side by side in source code form at least. Okay, so as I mentioned in io.c, the Bresenum line function is used for both drawing lines and also line of sight. And the initial part of the code, and here we're talking about line 55 in the source code of being.c, starts this idea of, you have this notion of walk on water, which basically just means that if point on the water is at the below the water level, then it's at the water level, and this is used specifically with regards to the line of sight. So anyway, we move into being draw structure, which is the memory information that's passed through the line of sight version of line draw with regards to the starting Z, the offset X, the offset Y, and the underlying land information, which is all that needs to be passed through. The next function, being ground, is in the same format as what we called previously, I think, draw pixel. This is the function that is basically applied to test whether the line of sight circumstances are met. And this basically finds cuts in the Z, things that will block the line of sight view specifically, with the view that, explaining the line of sight. You've got 2 points on undulating landscape, and you draw literally like a three-dimensional, like a laser pointer or a piece of string between these 2 points. And the logic is that anything that cuts this piece of string blocks the line of sight. It's not just that you're taking points and tracking the Z values, it's that you're taking points along a piece of string. It's actually a line along the string, so you don't run into problems where if you were just tracking Z values, for example, you'd have to go up a hill and go down a hill and go up a hill and go down a hill before you got to the other point, and then, then track it. It's actually literally like a point that is the line of sight, and you're finding anything that cuts it. And being ground represents the calculation at each point along this piece of string or laser or what have you, between these 2 points that you're checking the line of sight with. And for this reason, it is really creating a local Z value and then seeing if the map Z value underneath cuts the local Z value, which means that basically it can't be seen. So that's what being ground does. Slightly misnamed, because it's probably better called being laser or being piece of string as opposed to just the ground. But that's what it does. And then we move on to the being line of sight function at 83 in being.c, which sets it all up. It works out what the gradient is associated with this piece of string, finds the starting points in the maps, goes through all this stuff, common divisor, sets everything up, and then uses the IO join as if it was joining points along a line to basically just play through with the being point function as previously described in terms of finding the line of sight information. 0 is fail, 1 is fine with regards to being line of sight, or being loss as it's written. The idea of moving a Noble Ape has a combination of components within the simulation itself, and this is really talking about the simulation core. Obviously the apes move around through the direction facing and also their relative velocity. This method works internally, however there are various instigations. For example, you may want to pick up an ape with the mouse and move it somewhere and these kind of things. So the being move was originally constructed as a kind of movement interface both within the simulation core and also within the external world. So this is described at line 151 in being.c, describing the kinds of movements. Kind 0 is just changing the facing direction which is used. Kind 1 is moving forwards and backwards along the direction facing as described. And kind 2, as I say, is this kind of cursor drag where basically you're grabbing an ape, shifting along the XY, it doesn't matter whatever else is going on underneath. And the view originally, this is very old code as well, I mean this is some of the oldest code in the simulation. The view originally was that some of the drawing would be handled, there would be a drawing interface where the core would go back and say, hey wait, you're going to redraw the ape. And this has in fact changed. So originally, being move actually had a lot more code in it that worked out whether things needed to be redrawn, all this kind of stuff, and now it's just an interface point basically for moving an ape either along the X or the Y, changing its point of direction, or just letting the ape move along the direction facing. So that's being move. Whether or not the ape is awake is relatively important, and we're now looking at being awake line 191. A whole lot of stuff happens to the ape. Obviously it sleeps, it has situations where it's swimming, it has situations where it's kind of, going to sleep but still eating. That's a critical point. And then it has a situation where it's, it really wants to sleep but it's still moving, so it needs to slow down. And then it's just asleep. And being awake is just catching all of these things explicitly and returning a value indicating, I'm still moving, I'm still awake, I'm getting tired, but, I'm moving towards sleep, basically, and then I'm asleep. And that's what the being awake gives. Being cycle, if you want to describe the Noble Ape movement specifically, it all really should come through being cycle. Being cycle used to do a wide variety of other things, and now it just handles the Noble Ape movement, and I think, if I'm not mistaken, possibly also, whether Noble Apes are born or not. Movement including birth, that's what being cycle does. If we go through the source code, it takes in the number of beings it needs to take in that, because it also includes the Noble Ape interactions, the landscape, number of Noble Apes, and the date. The date's important, obviously. If apes are going to be born, they need to know what day they're born on. Well, they don't explicitly, but basically the simulation needs to know when they were born so they can calculate relative age, that kind of stuff. Finds the location of the ape, assumes that the ape is asleep initially, gets the land location, works out whether the ape is swimming, hungry, or awake. It then creates vectors associated with the direction facing, has a temporary speed that it starts moving in, and then works out, this A, ZX, A, ZY. The amount of effort that the ape has to take to move, obviously, it can be a very steep hill climb, climbing up, these kind of things. Ironically, there's a distinction between the movement section, which is handled in that very simple being move, and then the amount of energy taken in order to move, which is handled within being cycle. And obviously some of this distinction is associated with, like I was saying, with regards to kind of grabbing the apes and these kind of things. You don't want a situation where, you're grabbing an ape and it's causing it like a huge amount of energy in order to move, because basically you're taking the energy with your mouse point in order to move that ape. It would be horrible to tax the apes with regards to this kind of godlike hand grabbing them out and replacing them somewhere else. The temporary speed, similarly, is also based on the difficulty that occurs. However, this use of temp speed is just a temporary value. Maybe it's like a resistive speed in this circumstance. Anyway, so if it's not swimming, it's awake, and it's not moving. It's the not moving part that's critical. Because basically the apes slow down to eat. And when they stop to eat, that indicates that is the new hunger condition. Which means that basically they stop to eat till they're close to being full. So that's what that line says. 265 in being.c. If it's stopped, then it's eating, then its definition of hunger is actually getting to the point where it's relatively full. Then it sets up the states. These state reporting in terms of being state awake, being state hungry, used primarily in the XML phenotype, but maybe used other places in the simulation, so it's a setup currently for that. It sets up the states for use in XML, the XML phenotype. The apes generally try to avoid water wherever possible, and this sets up the avoidance of water. Again, this is almost like a turn towards, but it's not a turn towards. There's no way you could really do turn towards with this, because turn towards is a vector specifically, and the water is not a vector. The water can actually surround the ape, so this is why turn towards isn't used in this circumstance. I'm looking at 297, 298 and being.c specifically. So what happens here is, if it's looking forward into water, it has two options of turning either way in order to avoid the water. It's making the decision based on an increment. So if the water is kind of just in the distance in its field of view, then it'll turn slightly. If it's like right in front of it and like a wall of water, then it will turn more dramatically. And this is what the water turn variable does. It just basically increments until it's found a comfortable place within that spread to do its turning. So variable turning length based on the water in front of it, and that's what it does. All this stuff is hard-coded, and this is really something that's interesting with regards to being.c. Increasingly, the hard coding associated with this will be removed, but it's just here currently as kind of implicit survival mechanism. With the view that when it's not there, and I have tested it without it being there, you just get kind of massive amounts of Noble Ape drowning, and it just sucks. So still a bit of hard coding in the simulation, and this is one of these sections. There's logic associated with slowing to turn. Originally it was just in the non-swimming, but I thought why not include it in the swimming as well? If it's turning then and swimming, so much the better, and I think that just makes logical sense. In the other circumstance, so you've got the swimming, water in the future, move out of the way of the water in the future. So if it's swimming or it sees water in the future, which is 297, 298 in the line numbers, then it does the turning. Failing that, it's thinking about breeding. If it sees an ape of the opposite sex, then it turns towards it. This is a simple scan through. This is going to be really interesting, and probably this code is going to be removed in a similar time frame to the movement into OpenSim, but this code in particular is going to be very interesting for OpenSim. And this basically is it creates a societal component to it as well. It's not just purely about breeding, but it does a check somewhere through here in terms of relative ages of consent associated with the apes. But here again, I think this section of code uses turn towards explicitly. The first thing it needs to do is just go through a series of checks associated with whether it can see the other ape, whether the ape's in front of them, a wide variety of other factors. I don't think there may be some genetic selection component to this as well. This might be something to add in the future if it's not in here explicitly. But finally, the line of sight is the most expensive thing, so it needs to go through a wide variety of things before it actually does a line of sight confirmation that the apes can actually see each other. If the ape does see another ape, then it does, as I say, the turn towards. Here we are at line 372 and being.c, continuing on. Turn towards the other ape if it's within a relative distance of the other ape, and here's where it does the age and maturity checks, does all this kind of stuff. Then it sets, in the case of it's a female ape, for the female to be reproducing, and they talk. The speaking here, again, more heavily used through ApeScript, and this is something that I'll say that ApeScript really is the window into the simulation of kind of best practices, whereas the previous hard-coded version of the simulation, not so much. So my view is, with regards to speaking and all these other things, that ApeScript is the way to go, and this really puts the burden on the user in some regards to actually produce better best practices through ApeScript, because the hard-coded simulation is really just designed to be set off and run and create who's and ahs, whereas ApeScript is really where the hard simulation goes on. Sets up the speaking, shows that something is speaking, and continues on. We get to the addition of energy if it's consuming food. This was the thing that caught me a little earlier with regards to the hungry state being set. When the speed was set to 0, it just means, eat until you're full if you're stopped. And a wide variety of speed normalization factors, including how it accelerates. It decelerates at 3 times faster rate than it accelerates. This, again, probably easily removed with ApeScript. It just is a kind of description of the physical characteristics of the Noble Ape more than anything. And I decided to throw in a random wonder, and this has been added and subtracted through the history of the simulation. Really, it should be based on the direction of the landscape and various other factors. I mean, you could construct a kind of thought experiment where, even if you were walking up a steep incline or what have you, random wonder would be less important. But anyway, that's the nature of it, and then it sets all the variables and sets the state. And that is being cycle. Being selection, this is associated with natural selection, this is part of the genetics, and we are at line 434 in being.c. This is designed with, mother-father contributing genetics. The notion of dominant and recessive genetics is also encapsulated here, and this just does the selection based on the values. It's got an explicit selection, and then it's got a random selection, so that's being selection. And it's used in being genetics to actually do the genetic component. Again, the genetic model here is dominant recessive, parental contributions. So there are 16 genetic traits that are currently represented in the Noble Ape simulation, again using the method described. It takes what I call primary and secondary, I think maternal and paternal specifically. It has a randomizing component to give the genetic output, which again is a 16-bit number. This will, of course, be expanded in the future, but the 16-bit currently work very well in terms of, I use it really for checking genetic descendancy currently. And in terms of its actual mapping onto the simulation, again, mainly through ApeScript, but in terms of actual exterior mapping, just descendancy and sex for the time being. It's something which I think folks in ApeScript can utilize for wide variety of factors in the simulation. I'm interested in particular gastric effects. I think would be really fascinating. Apes that can eat only a certain kind of food and how that actually works out in terms of a broader society and these kind of things. But that's the genetic part of the equation. Being INIT, if you've reached the maximum number of possible apes, then it's no good to have any more. It's the first bit. We are at line 475 in being.c. Again, creates a local version of the ape being simulated, local version of the land, carries through some local random number generations. If they are the original apes, then they do not have fathers. However, if they're not the original apes, they'll have fathers, in which case the genetic construction, if they have fathers and mothers. We go through the code from, the first section of code from 492 through to 513 is obviously associated with the original apes, who have no fathers and mothers. And then the code going on is to do with those with fathers and mothers. And this, I think, is particularly interesting because I guess when I did the long-term simulation cycles, when I was doing centuries of simulation, like 3 centuries and stuff, I found there was a small chance, in fact an increasingly small chance now, because basically I fixed a lot of the genetics code, but there was a small chance of really heavily dominated either male or female and the potential for the simulation to die out. So I did put in a slight fudging factor here, and this really isn't applicable anymore because I fixed the underlying bugs. But there is something that will just very occasionally randomly select towards either male or female to counteract what may be extremely dominant in the case of the simulation. So if you get a situation where I think the ratio is 1:4, it will very occasionally randomly select in the other way. And that's just enough to make sure that the simulation kind of continues to run in a meaningful fashion. It's sufficiently small to be statistically almost insignificant, but certainly having an overarching effect in the long term running in the simulation. This is another section, obviously, that I'd probably cut. In fact, having fixed the bugs, I probably should cut it. It really is completely unnecessary in terms of the addition of code that it adds. Meh. So this was a bug fix cover code where the bug has now been fixed. It's still in there. Here I'm looking specifically from 545 and being.c. Sorry, really 547 rather, where it takes the comparison of men and women, it works out which is more dominant and fudges the code accordingly. As we get down to 582, setting up the facing, the energy, location based on birth point, date based on birth point, not speaking, stays 0. This is an important one to note. So randomization is actually done per ape. And this was something that I pondered for a long period of time, and then the solution came to me because through the threading of the simulation, you want to replicate a situation where basically, irrespective of whether you have a 1-threaded machine or a 15 or, a grid computer all simulating a Noble Ape simulation, at the end you'll have the same results if you maintain a constant random through. And the way it had been done previously was that there was a kind of central randomizing seed which was used for everything. And in the case of obviously 2 or more threads, this seed would get completely out of whack, and the solution really was to have initial randomization associated with the generation of the landscape, and then have that kind of proceed on in a very causal fashion, and then have the randomization passed to each individual being as it's born. It's given a random seed, and this ultimately creates the randomness of its life. And this was the view that each ape would then be farmed out in a grid to a different processor, and that meant that the random within the apes would remain internally consistent as if whether it was on a grid or whether it was on a single machine. That's why randomization is connected with each ape, and in the future each feline and ape, etc. And then we get to the brain states, and really I'm debating whether or not to actually go through being.c because there's a chapter in a book about how I do the Noble Ape cognitive simulation, and it may just be easier if I took excerpts from the book and read from it in order to explain this. But there are these ideas of awake and asleep states that are replicated or that are described here by these numbers. And here I'm talking specifically about line 600 in being.c and the lines following it. And I note, these magic numbers were found in March 2001. Feel free to change them. And that is the history of the cognitive simulation. After 2001, aside from some very minor tweaks, the cognitive simulation was at a point of numerical maturity. Let's just call it that. So that's what it was. And that memorializes the date, which is always good. Being tidy function in 615, line 615. What this does is, this actually moves the apes. So scratch what I said previously with regards to the move function being used to move the apes. Why did I do this? I think I did this because at one stage I was going to create a specific vector library, and this isn't here vector computing, this is here directional vectors. And I think that's why I introduced this specifically. But anyway, the being tidy function handles the movement associated with each ape. It handles the energy loss associated with each ape. I think this might be also based on some of the feedback that I got through the threading component, that I needed the movement. I think there's a need that these things be encapsulated for the view of threading, that this is a relatively fast function because it just goes through and moves all the apes, and it's better atomized, let's just say, than the being cycle. So being tidy does the movement and energy usage associated with movement. So line 682. This simulates natural death or at least some trauma to the ape that the ape may or may not be able to recover from. And the issue here was the various elements, things like drowning and starvation and these kind of things, which basically can screw up the apes and kill them. However, certain landscapes and environments are created in almost like a utopian way, and unless there's some element that simulates things like organ failure or breaking a leg or doing things that just getting old is associated with, really the apes could kind of continue outside natural parameters, and really it's just a flaw in the simulation associated with this. So here I wanted to create something where things that just simulate things like broken legs, organ failure. Well, organ failure is pretty extreme, but anyway. These kind of random events that may occur that may actually bump an ape off after it reached a certain age. And I think in general most of the apes will die prior, but this is just like super old apes. Here 29 years, possibly maybe extended, but I think this is what I came from, kind of long-term simulation, and they get like a substantial hit to their energy, which one may or may not kill them, depending on how much energy they have left. It does the male-female calculation here, which is kind of strange that it does it prior to actually removing the apes, but anyway, it's done prior to removing the apes. Works out if all the men are dead or all the women are dead, what circumstances, and failing that creates some normalized value that indicates a ratio, and here it's an integer ratio, so, it'll be 1 to 1 in most circumstances. If there's just a huge number of one rather than another, maybe 1 to 2, 3, 4, what have you, but that gives the kind of delta differences. This section of audio was added after post-production, but as I'm listening to the audio, the critical thing that I miss here is that being cycle, the function being cycle, is actively replaced by ApeScript. So the sections associated with movement and all the stuff that I talk about, the sections associated with turning the ape's direction, all the turn towards associated with finding a spousal mate, let's just say, spousal ape, relates to sections that are actively replaced by ApeScript. But being tidy, the thing that actually moves the apes and calculates the energy, is run separate from ApeScript, as is being removed and all these other sections. So the stuff that I don't see with regards to why being cycle is the way it is specifically relates to how being cycle has been replaced by ApeScript fundamentally. Back to the previous recording. Then we move to being remove, which again, like being tidy, is just the idea that there needs to be a single encapsulating function that does all this stuff because it will have been farmed out previously. You don't want kind of apes dying on their own respective servers. It needs to be kind of centrally reported. So here we have being removed. The standard is no apes found, and then it just goes through, checks the energy states, moves stuff over, moves the brain over if they've died, and then returns the number of apes and the selected ape. The idea of the selected ape is really a graphical idea, although it is used in some regard to pass into ApeScript and other things. But the idea of the selected ape is graphically which ape is selected through the simulation, and obviously if some apes die, you want to keep tracking the selected ape even if it's moved around in memory accordingly, unless the selected ape can actually change through being removed. Once again, another kind of epic audio journey through a source file in the Noble Ape simulation, thus proving that this was going to be a kind of extreme walkthrough. But that's being.c. Just before I conclude, I wanted to kind of talk a little bit about core.h, and I'm kind of getting this feeling because you don't probably get a real sense of what the apes are or how they're represented or even the simulation is through discussion so far. So I'm just going to talk a little bit about core.h before I conclude this recording. So open up core.h, ladies and gentlemen. You'll see a wide variety of defines and undefines, and these kind of things are increasingly on the way out. I just want to have them defined by pointers. Here again, line 49. We see the transition between map to screen, screen to map. This is the idea of coordinate mapping versus the screen mapping. Make sure that the bytes are positive. Find the bounds of the coordinate mapping. Various wrapping functions. How water is defined on the map. How clouds are defined. How rain is defined. And the movement of the weather memory as previously discussed. Whether the apes are male or female. The age of maturity. This is in days. 30 days old, the apes can have kids. It's going to have to change in the long term. There's various Apple Chud related stuff, which is how Apple uses a Noble Ape simulation. They like to start during the day. I like to start in the night for the initial simulation. Time related stuff, days, minutes, years, centuries. There are no apes that have been found versus zero apes. There's a subtle distinction between those two. Takes the coordinates from an array. So you've got the land array underneath, and it's just finding what value the land array has underneath. It's a quick land idea. It takes the land on the map. Water test is the land value below the water, then it's in water. Map water test, which is exactly the same, but through the coordinates. Actually, no. Water test just gives a Z value, map water test gives land values. Defines day and night in terms of the values divided by 32. Here's night, here's day. So I started using header doc for a period of time in order to make core.h work, and didn't really. So there's some legacy header doc related stuff. This is what defines the Noble Ape land structure at line 118 in core.h. The time, the date. The date is in days and centuries. And the underlying genetics that went into the creation of the land. And then the big array that is the map. Then we get to the Noble Apes, their locations in the X direction, their location in the Y direction, the direction that they're facing, the speed that they're travelling, the energy that they contain, their ID number, which is their genetics, their date of birth, whether or not they're speaking, and their random seed associated. If they have a brain on, which almost all instances in the simulation do, they have the 6 brain state related values, the underlying brain, and the state which went into the X phenotype and is not really explicitly used. Then we have the various state related awake, asleep, awake, hungry, swimming, eating, moving, speaking, reproducing. The explicit size of the beings and the land and the largest possible size of all this information. This is used with regards to the initial memory allocation. We then get into, as I was describing with io.c, the list of command simulation variables. So the fact it's a sim object, the signature, which describes it as Noble Ape simulation, Noble warfare, etc. And the specific version, the land variables, which obviously has the time, the date, and the underlying genetics. And as you'll see, 1 component for the time, 2 components for the date, and 2 components for the genetics. So yeah, if you see at the bottom, it has character 1, character 2, character 3, open brackets are equals, inclusion, which is the object type. Then you have the kind, which is defined as either a 2-byte or 1 byte, so 8 or 16-bit variables. The number of, and the base byte. So basically as it moves through the structure, how it's padding byte-wise in terms of what goes in. So that's the elusive commands that are passed in with regards to the file in and out currently. We then have the atmosphere with regards to Noble Weather, the Noble Weather struct at line 199 in core.h. Total pressure, which is, as I've described, the normalizing. And then we have the Noble simulation structure, which contains the land, the weather, the beings, number of current beings, the maximum number of beings, currently also the female and male ratio. This is not the number, but this is in fact the ratio, where one of those will be 1 and another will be another number to represent the nearest integer ratio. The being that's being selected, and over the whole simulation, is anyone talking. The get stuff is from the vectorized code, but it's included in some circumstances, so it's not a lot of really interesting stuff there. And then we get into the functions that we've already discussed. So that is core.h, and that kind of gives an underlying indication of what the Noble Apes are and what the simulation is in kind of data sense, and also explains the file handling related stuff. So this is Tom Bartley in Las Vegas, Nevada, signing off for another one of these. I'm not sure which direction we'll take. I may look at control.c next. Tom Bartley in Las Vegas, Nevada, signing out.